Hello, this is Rick Gupta with AC&E. This is the second video in the series of the Vision application module. This one we're going to concentrate on semi-automatic teaching. We're going to show how we can use this simulated vision sensor by this prism to scan this entire surface. So the first thing we're going to do is select the surface that we want to scan. So here we say we can either select all surfaces or just a selected surface. We'll just select this one, we'll select that surface, and then we'll go on. Then what we can do is, if you notice, it creates two different directions, two different arrows. There's a stacking planes. We're going to slice this part using a slicing that follows the contour of it. And so the scan direction is from left to right, and then the plane slicing is this way. And we can use these values here, these parameters, to change the direction and scan the other way and slice the other way. And then we can actually change it so that you can do it on a rotary table or at a slant. There's a lot of different aspects we can use to slice the part. And then we're going to create the acquisition point. So we're going to use, this is in millimeters, so we're going to use 500 millimeters and 500 frames. Okay, there's the slices. Okay, looks like we've created 500. We want constant spacing at 500. So every 500 millimeters we want to create a there we go. Okay, and we're going to change it to be in this S order as opposed to the Z order, and so there we have the frames that we've taught. And I mean, it was pretty easy, pretty slick, and we actually create a program already. So let's look at a few details of this. Let's use all that information. Okay, so we have to change the tool. So the tool on the slicing is the same as the tool that we're using, which is our sensor, our vision sensor. But now what we can do is we can use those paths that we just taught. There we go. So that's pretty slick. We already know, we've already created the whole path that we need to cover this surface, and it's been pretty painless. So let's go back and look at some more details. You can see there's 21 data acquisition points. Let's go back and look at the let's do a surface analysis of that, figure out how much we've covered. First thing you'll notice here, this acquisition does not cover the whole surface, and so what we don't want to do is we don't want to scan the whole possible scanning area. We don't want to scan half of it and send that to the sensor. So we have a way of telling when we write it out, we'll say, okay, we only want to scan this section of it on the first time. And this kind of shows, if you click here, it shows the scanning region, the actual scanning region that we want. Okay, so let's go back and analyze the entire surface here. Okay, so let's look at the coverage graph on this. So here's a couple things we can notice. One is the first scan is only about half the area that we've seen because it only covers off. And then after that first row, then there's the finishing one and the next one coming back that is going to cause this kind of dip in the amount of coverage. It's kind of a linear coverage to here, and then it dips, and then it's a linear coverage again. But then we do get really close to 100% of the coverage here. Okay. And we can also see that if we look at the overlap is around 12, which is maybe not the best. We could sharply change that to depends on the application, but we can increase the percent overlap. And then here's the program that we wrote. And so if we write this program, we can show the data acquisition happening, and then we can actually save that to a file and use that on an actual scanning system. All right. Please let us know if you have any questions. Thanks.